Come on, everyone. Let's go ahead and begin the demonstration of week 4 challenge and participation activities from the ZyBook. What I'm going to do here for section 4.1 was terminology, so there wasn't any problems per se to work on that one, but I'm going to go ahead and start out with this first participation activity and go through the underlying calculations that are involved here. So a couple things that we need to identify to come up with utilizing empirical rule. One thing I'm going to do off to the right here and just kind of explain from that perspective. If you are talking about the number of standard deviations and what percentage relative to that, if you are within one standard deviation on each side, roughly explains about 68% of the data. 2 of them is roughly 95%, and 3 is literally almost everything underneath the normal curve, roughly 99.7%. So we're in essence going to help us use that to help us answer these particular questions here. So the first one says, what percentage of seniors took the test in 2015 scored between 271 and 751. So the first thing, I'm just going to list this out to help give a visual of it. So I've got the mean, standard deviation. I'm going to identify what this lower bound is and upper bound, and I'm just going to key in these corresponding values. In the original problem, it told us the mean was 511 and the standard deviation is 120. Now, what do I mean by upper bound and lower bound? Lower bound would be the lowest range that these numbers fall between, which in this case is 271. The upper is 751. So for this one, I'm just going to key in 271 and 751 respectively. Now, what I'm going to do is I'm going to calculate something called a lower z-score. Now, to get a z-score, the way you do it inside of Excel, you're going to do an equals, open paren. You're going to take your observed value. Well, your observed value is located right here. So I'm doing a left mouse click on cell B3. I'm going to subtract off the mean, which is in B1. I'm going to close the parenthesis, divide by the standard deviation, which is that 120 that's there. That's going to get me a -2. The next thing I'm going to do is I'm going to do the upper z-score value. And I'm going to do a very similar calculation. I'm doing equals, open paren, the upper bound, the observed value, minus the mean, over, close the parentheses, and then divide by the standard deviation. Now, you'll notice here, these z values, the -2 and 2, represents 2 standard deviations relative to the mean. In this instance, since it's 2, we end up with 95%, and that is by empirical rule that I stated over here from the earlier readings. The other way that I can verify this is by way of utilizing probability, and they talk about inside of this section something called normal distribution, NORMDIST. What I want to do is I want to calculate the probability between -2 and a +2. The way that that is done, I'm going to take that value, comma, for standard normal distribution, the mean is always 0, the standard deviation is 1, and that last parameter is always a true statement. I'm then going to subtract normal dist, and I'm going to use the lower bound, which is that -2. Standard normal distribution always has a mean of 0, standard deviation of 1, and then do a true on that. And you'll notice as a decimal, I get 0.9545. If I come up here to the ribbon inside of Excel, do a percentage on that, notice I get 95%, which now if I check that, notice we end up with the correct probability and the correct answer on that first question. Now, for part B, I'm just going to do 2's probability here, so show the difference. And I'm going to use the same set of data here, but I'm going to change the upper bound to the value that is given here, that's 631, okay? So from 631's perspective, here's what I want to do that. You'll notice for 631, it calculated a upper z-score of 1, but there is no lower this time. If you do something that is, quote, upper or to the right or more than, you always have to take the complement of it, which is going to require you do an equals 1 minus norm dist. You're going to use that z-score. The parameters of the mean and the standard deviation still stay as 0, 1 respective, and you're going to do a true. If you do that, convert that to a percentage up here, you'll notice you get 16%. So approximately 16%. And notice you've got your correct answer that's there. Now for the third one, I've got 271 to 511. This 271 is my lower bound. My 511 is my upper bound. So I'm going to change that to 211 and 511, or 271, excuse me, let me change that. 271, and I got 511 there. If I do that, the probability is going to be what we just did in that previous formula, the 48%. Of these three values, which one's closest? 47.5 gets us to our respective answer. Now for part 4, let's look at what we've got here relative to 2 standard deviations. I'm going to go back and I'm going to look at this first problem here. And this kind of gives us the hint, the 271 and 751. And let me get my pen active here so you can kind of see what I'm analyzing here relative to this problem. Okay, there we go. All right. So if I'm looking at this guy, the 271 and 751, you'll notice that that is -2 and +2. If I look at from a normal curve perspective, this is where 271 is and 751. This is where z was -2 and z was a +2. You'll notice the value that they give you, the 770, is to the right of our lower bound, LB standing for lower bound and UB standing for upper bound. Typically speaking, if you have a z value that is greater than -2, or excuse me, greater than a +2, or less than a -2, that is considered to be unusual, because our normal tolerance is going to fall between those respective values. 770 is outside of that given normal tolerance that explains 95% of the data, and that is used via the ZyBook's definition here, that anything greater than that 751 or less than that 271 would be considered unusual. So I would select yes there, answering that problem. That completes the first problem there. Next participation activity, we're given the mean, we're given the standard deviation, but we need to figure out what observed score is based upon the given information that's here. We're in essence doing what is referred to as an inverse calculation. And you'll see that relative to when we set this up here. So I'm given some information here. I'm given a mean, standard deviation. I'm just abbreviating STDEV for standard deviation. And then I'm going to be given a percentage. And that'll come into play here in a second. So on this first one, we have a mean of 150, standard deviation at 8.75. So 150, 8.75. Now, on this particular one, you need to look at, when you're reading this guy, you need to determine whether you use the percentage that's there or do you apply its complement, i.e. take 1 minus the given value. For this guy here, and let me get my pen active. For this guy here, it says below. If you see the word below, you do it as is. If it's above, you have to take 1 minus that given percentage. And you'll see why here in a second. For this first one, we're going to key in that percentage as is. For the second one, we're going to have to take 1 minus that value as a decimal. Now, for this first one, 40%, 40% as a decimal is 0.4. So all I did is move the decimal place 2 units to the left to represent that as a percentage. Now, our observed value, or the value that we need to calculate, is a built-in intrinsic function inside of Excel. You're going to start with an equals. You're going to do a norm INV. So that's going to be your starting point. Open parenthesis. Your probability is the given percentage, what we just keyed in there, the 0.4, comma. Your mean is the 150, so I'm referencing that cell. And then the standard deviation is the 8.75. If I hit enter, you'll notice we get the 147.783. 147.783. Now you notice on the number, they've got this pound, pound, pound there. That means they want 3 decimal places when that's keyed in. Check it, and notice we've got our correct answer. Same song, different verse, just a slight bit difference on number 2 here. The mean and the standard deviation hasn't changed, so I'm utilizing that and that. From the percentage, notice this guy has the word above. I got to take 20% and apply its complement. The way you're going to do that, if you come over here and you do an equals 1 minus 0.2, the top 20% is referenced as the 80th percentile. As the 80th percentile, you need the percentage to be 0.8 on that one. The observed value is calculated the exact same way that we just did a minute ago. So you didn't have to change the formula, you just had to change the corresponding value up there as the percentage. In this case, if I come over here, it's 157. Oh, let me key in the rest of it, 0.364. Check it, and notice now we've got our corresponding correct value. Just a comment, norm.inv and the way that I did it up here is going to yield the same result. The norm INV without the dot in between is the older way inside of Excel to do it. This is the newer way. Both are going to get you the same result. So you're welcome to utilize either one. If you're more comfortable with using the one that the description of the answer gives you, is fine, or you can use my version of it. 6 a good, a half dozen of the other. You're going to end up with the correct answer regardless. Let's go to the next one. For the next participation activity, we have a set of data that is given for men. We're given another set of data relative for women. So for this first set, I'm going to go ahead and type out, because we're going to need the mean. We're going to need standard deviation. We're going to need the observed value. And let's see here. And I'm just going to go ahead and let me delete out that line there. There we go. Because I'm also going to need another set of values here for mean, standard deviation, observed. This first set I'm going to work with is going to be the men data. The second set is going to be the women data. So it says, according to the U.S. Department of Health and Human Services, the mean height for Americans is 1.757 for men. So 1.757 is what I'm going to key there. And then for women, it says it's 1.618, because we're going to be doing a separate calculation for the men as well as for the women. Standard deviation is 0.074 for men. And then I'm going to come down here and do 0.069 for the standard deviation there. On this guy here, it says the man's height, the observed value is 1.853. And on problem number 2, it is 1.758. Now we need to calculate the z-score. I'm going to put man there, and I'm going to do z-score for woman here. All right. To get a z-score, you start with an equals, open parenthesis. It is always observed. Well, your observed's there, so do a left mouse click to do the cell reference, minus the mean, divide by the standard deviation. Gets us that z value. Again, open paren, observed minus mean, close your parenthesis, divide by standard deviation, gives you that. Now notice on these values, they say pound, pound, pound. That means 3 decimal places. You'll notice up here, it's got multiple decimal places off to the right. A nice little trick from Excel. Come here, and where you've got this selected here, if you do a round, R-O-U-N-D, do an open parenthesis, click on the very end. How many decimal places do we need? We need 3. Do a 3 there, close your parenthesis, it will round it for you. Same deal down here. Let's show that again. I'm clicking inside there, making that a round, doing another open parenthesis, go to the end, comma, 3, close the parenthesis. Notice now your values are keyed in there accordingly. So let's make sure we did that correct. 1.297, check it, and we're good. 2.029, that's what we calculated there, 2.029. Check it, we're also good. And then on the last part, it says which one is respectively taller. The way we determine that is by these 2 values that we just calculated. Whichever one has the larger Z value is the way that you answer it. Notice the woman's Z score is larger than the man's Z score, so they want you to type in either man or woman. Since that Z score is larger, we're going to type in as is. Make sure it's all lowercase. As woman there, check it, and we've got our correct answer, completing that participation activity. Okay, challenge activity 4.2.1. We're going to use empirical rule, and at the beginning of this presentation, if you recall, I stated that standard deviation of 1 represents approximately 68% of the data, 2 represents 95%, and 3 standard deviations is literally the whole enchilada, the 99.7. So here's what we've got. We've got a mean standard deviation. I'm just going to abbreviate that as STDEV there. And we are going to end up calculating in this instance the lower bound and the upper bound. Let me make that just a slight bit larger there. There we go. And I'm going to delete out those 2 columns so we can see our chart here. Okay, there we go. All right, so the mean in the problem was given as 133,000. The standard deviation is 7,000. Now, to get the lower bound in this case, you're going to start out with the equals. You're going to start with the mean minus. Now, it says approximately 95%. 95% represents 2 standard deviations. So I need to reference that 2 there times whatever the standard deviation is. That's going to get me my first value. This formula here, if I copy it, I'm going to highlight that, do a Control-C, come down to this formula, come back up here, paste that in. The only difference between lower bound and upper bound, instead of this here being a minus, you're going to the right, which means you're going to add instead of subtract. If you do that, your upper bound is 147,000. So let's verify I did that correct. You got 119,000 and the high price of 147,000. Check it, and we've got our 2 correct values there. Next one, we're analyzing the graph here, and it says, okay, Z-score between -1 and 1. That is the reference from the center or the mean to however many standard deviations are between it. So for this first one, this would have been a Z value of -1 and a Z value of a +1. This one here would have had a Z value of -2 up to the middle, which is our starting point, which is 0. This one goes from -1 of a Z value up to 2. So between -1 and 1, the one that makes the most sense is that one. Check it. And we've got our correct answer on number 2. Let's go to 3. Okay, utilizing empirical rule, says find the probability selected to the shaded region. Now, I'm going to kind of go back to this here because we're going from the mean up to one standard deviation. Couple ways we could approach this. This is 68% is from -1 to a +1, or if I scroll all the way back up here, notice between the center to the first standard deviation is 34%, which you agree if you take 68 divided by 2 there is 34%. So either which way, we know it's 34%. So I'm going to come back down here to this guy. The percentage is already out there, so I'm not going to rekey a percentage in. It's going to be 34, check it, and we've got our correct answer, completing demonstration of that first challenge activity. Next challenge activity, here's something we need to take into consideration. I'm going to kind of draw on here. Notice it says a football coach finds run times for 50-meter dash normally distributed. That's kind of important there. It says a new player runs a time with a z-score of 7. If I look at the normal curve here, smack dab in the middle has a z-value of 0, which means that is also where the mean is located. If you have a positive z-value, that means you are above or more than the mean. Conversely, if you have a z-value that's negative, that means you're below or less than the given mean. So in this instance with 1.7, you're sitting over here. So that means you're either above or more than the actual mean. I don't actually have to go through the calculation because a positive z-value means that that value resides above the mean in that instance. So if I look at this on this first one, if I click that, it says the player's run time was, and your options, greater than, which is a more relationship in that instance. If it was 0, exactly 0, or the same, there would have been no change. But in this instance, since that z-value is positive, it is a greater than relationship. Let's do the second one here. Clear out my markings. It says new employees at a company are given a proficiency test. The test scores are approximately normally distributed with a mean of 250 and a standard deviation of 30. A new employee scores 274 in the exam. What's the z-score? Well, I need a mean, standard deviation, and I need my observed value. Well, in this problem, the mean is 250, the standard deviation is 30, and the observed, which is given to us in the problem, is 274. Z-score equals, open paren, it is always observed, which is that, so I clicked on that one, minus the mean, which is that one, divide by standard deviation. Notice I get a 0.8 as the z-score. That's what I'm going to key in, 0.8, check it, and that completes that challenge activity. Moving on to participation activity 4.3.1, we need to calculate a weighted mean and analyze whether 4 could be guessed as the mean population weight. Well, the sample means off here do not yield a weight of 4 in any of the observations. So honestly, there's no way that you're going to be able to come up with a population weight of 4 squash are chosen, because we don't know that from the weighted perspective. So I'm going to click no. And it says since the mean is 8 in the sampling distribution, the child cannot correctly guess the mean population weight at 4 squash they're chosen. But what is the mean of the sample weight? Well, here's how we're going to do this. Make this a little bit bigger. I'm going to create 2 columns here, X and P of X. I'm going to key in each of those sample means, the 6.75, the 8.75, the 8.25, 7.75, and 8.5. Now 1/5, we just need to simply do a division on that. That's going to yield 0.2. And the way we get there is an equals 1 divided by 5, which makes it 0.2. That lower right-hand corner, I'm just going to simply drag that down so I have those on all 5 of the rows. The next step I need to take x times p of x, which means I'm going to take the multiplication of those two values. So I'm going to do an equals that times that. And I'm not going to manually type those in because it's the same product or multiplication. So in that lower right-hand corner, I'm going to drag that down, which gives me those values. My final step for the sum, I'm going to do an equals sum, open paren, and use those 5 values to perform the sum on those 5. If I do that, I get back the value of 8. Key in the value of 8 over here, check it, and we have the correct value to that second part. Next participation activity 4.3.2. We are going to expand on what we did on the previous section, but add one additional thing via central limit theorem. Previously, our sample size was choose one out of the population. This time, we have a sample size that is given to us. So you'll notice I'm going to come up with the mean, standard deviation. I'm going to have an n, which is the sample size as well. So I'm going to key in 172. The Greek symbol mu is the representation of the mean. The standard deviation is that sigma, which is 29. And my sample size is 36. So I've got those 3 values that are there. Now, what's the mean? The mean of the population is going to be the same as the mean of the sample. So I am taking that 172. That becomes my answer for the mean. Now, the standard deviation of the sample gets changed slightly different. Here's how you calculate it. You're going to start out with the standard deviation that was given to you from the population. You're going to do a slash for division, and you're going to type in SQRT. SQRT is the intrinsic built-in function for a square root. So you're going to do SQRT, open paren, the sample size, which is 36 there. Close it. Your sample standard deviation is 4.83 repeating, but they only need 3 decimal places. Well, we did talk about earlier in the presentation, there is a trick. If you do an ROUND, change that formula at the end, do a comma 3 on it. This will get you the rounded value of 4.833 as they're asking to be keyed in. So 4.833. Check it, and now we've got our correct value. All right, last piece of this is now we need to calculate the corresponding probability. We got all of our pieces that we need to calculate this here. So what we're going to do is we're going to do an equals norm DIST. And again, you're welcome to use what comes up if you want to use norm.dist. I like this one because I've used it close to 30 years. So, but anyway, my observed value is at least 180. And then our mean is going to be 172. That occurs there. The standard deviation you're going to use is off the sample. We already calculated that there. So I'm going to use that, and I'm going to do a true at the end. That last parameter is always true for a cumulative normal distribution. Now, one additional thing we've got to do here. When this says at least more than complement, you always got to take 1 minus the value. So I'm going to come into this formula, and I'm going to modify this slightly. I'm going to do a 1 minus that value. If I hit enter, you'll notice I've got 0.04893. Again, they want 3 decimal places. So if I come back into this guy, I'm going to have Excel round this for me. So round, open paren, come to the end, do a comma 3, and I've got 0.049. So that's what I'm going to type in, 0.049, check it, and I've got the correct value there, completing that participation activity. Moving on with the next participation activity, it says nearsightedness affects 8% of children in a certain country. The eyesight of 256 randomly selected children are checked for nearsightedness. So I've got a mean. Mean in this instance is what we would expect. In this case, the nearsightedness is 8%. I'm going to key that in as a decimal of 0.08. What is the mean? That is the expected value in this instance. 8% as a decimal is 0.08. Check it. There we go on that. Now, to get the standard deviation, this is a little bit more involved. What you're going to do, you're going to start out with an equals. You're going to type in SQRT. That is the intrinsic built-in function for square root. Open paren. And then what you're going to do is you're going to type or click this 0.8. The 0.8 is the first parameter, a times, you're going to do another parenthesis, you have to apply its complement. 1 minus 0.08 is 0.92, but let's let Excel do that calculation. So I'm going to do a 1 minus that value again, close the parenthesis, divide by the sample size. Let me put the sample size in here so that everybody can see that. I'm going to insert a column. I'm going to make the n there, and we're going to make that 256. So let me start that again. Apologize. Equals SQRT, that times open paren, 1 minus that value again, divide by the 256, which resides there as n, or the sample size, close the parenthesis, hit enter, you get that. Now, 3 decimal places again. So I got to come back up here, make that equals round at the beginning with an open parenthesis, come to the end and do a comma 3. That's going to get me 0.017. So 0.017, check it, and we're good there. We got one more thing to do. We got to do the probability on this one. Again, probability, I like norm VIST. That's there. My X value is going to be the 9%. So 0.09 is my observed. The mean is right there, 0.08. And then standard deviation is what we just calculated, that 0.07. So select that, and then true, comma true. Now, our little glaring here of that at least, if that would have said less than or something along those lines, we would have just did the calculation as is. But that at least 9% requires, again, that I got to modify this guy doing a complement, 1 minus. So if I do that, you'll notice I get that probability back. But again, they need this as 3 decimal places. Again, let's let Excel do the rounding. So I'm going to do a round, open paren, come here to the end, comma 3, and I've got 0.278. Check it, and notice I've got the correct answer, completing that participation activity. Moving on to the next participation activity, 4.4.1, finding percentile on a t-distribution. Beginning of this presentation, we worked with normal distribution. If the sample size is less than 30, typically what happens is what's referred to as the student distribution, or sometimes also referred to as t-distribution. Why? Because if you remember back in grade school, typically your class sizes were 30 or less. That's why the kind of the correlation between t-distribution and student distribution kind of comes into play. How do you do this inside of Excel? Well, on this one, we've got our percentile, and we've got our DF, degrees of freedom. So for this one here, 25th percentile is going to be 0.25 as a decimal. Move the decimal place 2 units to the right, and the degrees of freedom is there. So in this particular case, to figure out the corresponding value here, or final answer, I'm going to come over here and do an equals. Now for this one, I actually use the newer one from Excel's perspective. It's actually a little bit cleaner. So do an equals t dot inv. That's going to get me the corresponding value that's associated with the 25th percentile with 30 degrees of freedom. First is your probability, that is the percentile, so reference that. And then your degrees of freedom is that guy right there, close your parenthesis, gives you that value. Now, notice again, they want 3 decimal places, so we're going to come up here, do a round at the beginning, at the end, do a comma 3 to get us to 3 decimal places. Notice now we've got negative 0.683, check it, and we've got our correct value there. Now, since we've already got the formula set up, good to go, we just need to change these values to get to our final answer. So 60th percentile as a decimal is 0.6. 4 degrees of freedom, change that guy to 4.271. So I'm going to come over here, 0.271, check it, and we've got our correct answer to the problems in that first participation activity in section 4. The next participation activity for this demonstration, we're going to go through, calculate degrees of freedom, as well as calculate the T-statistic and corresponding probability. So for this first one here, we are given a population mean. So I'm going to type in population mean there as 1.86. I am given the sample size, which is going to be the 15. Now, degrees of freedom, I'm just going to abbreviate as DF. Degrees of freedom are always 1 less than the sample size. Or if we did it inside of Excel, just reference that previous cell, subtract 1, degrees of freedom is 14. Hey, that's what it's asking on this first question there, so we'll make that 14 and we're good there. All right, so we got our sample size, we've got our population mean, and then it says on number 2, it says a pool of 15 households, so sample size or N has not changed. We do have a new piece of information, a sample mean of 3.26, and then a sample standard deviation of 2.12. So they want the T-statistic here. So how do we do that? We're going to start with an equals, open paren, and what we're going to do is we're going to take observed, which is the sample, minus the population. So I'm going to reference the 3.26 minus the 1.86, close the parentheses, do a divide, open paren again. This is going to be divided by the sample standard deviation, which is that one, a division symbol again, SQRT for square root. We have to divide by the square root of the number of observations, which is going to come off of our sample size, which is that. Close that and close it one more time. Hit enter. You now have that piece of information. Now, again, they want it to 3 decimal places, so I'm going to come up there, do around another open paren, come to the end, do a comma 3, close the paren, and I end up with 2.558. So 2.558, check it, and we're good there. So now if I scroll down, it's now going to ask for what is the probability of finding 15 households with a sample mean of 3.26 children or less. On this, I need to figure out the corresponding probability. So you're going to start out with an equals, and on this particular one, we're going to use the T dot dist. So our first parameter is what we calculated, that test statistic, the 2.558. So reference that cell, comma. Where's our degrees of freedom? It's right there, so I'm clicking on the 14. And then that last parameter is always true. So I get 0.988862. They want it with 3 decimal places, so we need to do a round on this. Come here to the end, comma 3, 0.989. So that's what we're going to come up with, 0.989. Check our answer. We've got our correct answer on problem 3. Let's go to the fourth one. Okay, this one says a different poll. I don't want to recreate all these given formulas this time. So here's what I want to do. I am going to copy, I'm going to highlight all of those cells. You can either use the ribbon up there or just simply do a Control-C. In cell D1, I'm going to paste this over because the population mean doesn't change, the sample size doesn't change, the degrees of freedom doesn't change, but in this case, the sample mean goes to 2.72 with a standard deviation of 2.12. That guy didn't change. So what's the T-statistic? And there is a reason why I copied it, because I'm going to use it in problem 5. But I didn't want to have to sit there and recalculate each time. So the T-statistic, that's going to be the 1.571 that's there. So we've already done our rounding, so we don't have to mess with that. Check it, and we're good there. And then the last one wants us to do a between. Between is always calculate the probability off the 3.26, which is that test statistic there. And then your 2.72 is what we just did there. Reason why I did the copy, and you'll see here in a minute, if I do a t.dist, I now reference that guy, degrees of freedom, which is 14, and make that a true there, minus t.dist again, utilize that test statistic, degrees of freedom, and make that true, hit enter. Again, I'm not rounded, so I've got to do that one more time here, equals round. Come to the end, do a comma 3, close the parenthesis, 0.058. 0.058, check it, and we've got our correct answer. This completes the demonstration of the week 4 participation and challenge activities. Thanks.